Hi everyone, my name is Peter Garwango from MUK Science Turing Center. Welcome to our YouTube channel, and today we are going to be discussing organic chemistry, and today's topic of interest is nucleophilic substitution reactions for alcohols. So under today's objectives, we are going to see how alcohols react with hydrogen halides and also how they react with the phosphorus trihalides and the sulfonyl dihalides. So now to jump into the topic of the objectives, let us begin with how alcohols react with the hydrogen halides. We know the general formula of alcohols as ROH. So alcohols have an OH group, which is a very strong nucleophile, very hard to be displaced under nucleophilic substitution reactions. Hence, we need to react it with any other reagent that will make this OH group a better living group. So therefore, when we react alcohols with hydrogen halides, we shall form an alkyl halide plus water. So this is an alkyl halide. So we are going to see mechanisms on how primary, secondary, and tertiary alcohols react with hydrogen halides. So now to begin with the primary alcohol, which is ethanol. When ethanol reacts with a hydrogen halide such as hydrogen bromide, we shall get bromoethane, which is CH3CH2Br plus H2O. So the mechanism of action of this reaction will be CH3CH2OH reacting with the hydrogen bromide. We know that this bond is polar because bromine is more electronegative than hydrogen. So we have a partial positive on hydrogen and a partial negative on the bromide. So the lone pairs of electrons from oxygen are going to attack the electrophile, which is the hydrogen, and then this bond will break off in favor of the Br. Then we shall have CH3 CH2O H plus Br minus. So you see that our oxygen has a positive charge, and this means that oxygen has to be bonded to 2, but now it has 3 bonds. It has to get rid of one of the hydrogen, or we have already made it a better living group. So with primary alcohols under SN2 reactions, it's only a one-step mechanism. So therefore, here we shall see that when this Br attacks, this group, this OH2 group breaks off at the same time, and this happens when this Br does what we call a backside attack. So the Br attacks this carbon from the back, and then this bond breaks off. Then we form our CH3 CH2 Br as our product plus the H2O, which is over here also in the first general equation. So therefore, this is how primary alcohols react. So now let us go into details and see how secondary alcohols react with the hydrogen halides. So for secondary alcohols such as cyclohexanol will react with hydrogen iodide. This bond is polar, partially positive, partially negative. So this lone pair of electron will attack the hydrogen. This bond breaks off, and then we form a high energy complex, which is this structure plus iodine. So the same case, remember we said that in primary alcohols that the reaction occurs as the nucleophile is attacking, this bond breaks off. For secondary and tertiary, it's really different. Since they can form stable carbocations, this bond can first break off then we lose the water, and then we form a carbocation. So this is a secondary carbocation, hence it's more stable than the primary carbocation we would have formed in a primary alcohols. So therefore, this is when our iron comes in and attacks this carbon, and we shall have iodocyclohexane as our product. Remember, there is stereochemistry in these mechanisms. With primary alcohols, we shall see that if your initial alcohol was an S configuration, due to the backside attack in the mechanism, then your product will be S. But in secondary and tertiary, due to the formation of a carbocation, when this iodine is attacking this carbocation, it can attack it in any direction. Therefore, we get two products, both R and S. So therefore, let us go further and see how tertiary alcohols react with hydrogen halides. So now we have this alcohol will react with a hydrogen. Let me use hydrogen bromide again. So this bond is polar, partially positive, partially negative. So the lone pairs of electrons from the oxygen will attack the hydrogen, and this bond breaks off in favor of the Br, and we form CH3 COH2 plus CH3 plus the Br minus. Again, like I said in the previous mechanism, this oxygen here has a plus because it's bonded to it has 3 bonds, and therefore this can break off, and then we form a stable carbocation on this carbon, which is tertiary. So therefore this is a very stable carbocation, and hence the Br can easily come and attack this to give us our new product, which is CH3 CBr CH3 CH3. So this is 2-bromo-2-methyl propane as our product. Again, like I said, if in stereochemistry, if they ask you for the number of products formed, we always form 2 products, both R and S, under this type of reactions with tertiary and secondary. So thank you very much for watching. See you next time as we discuss further the reactions of alcohols. Bye for now.